Imagine standing on a shoreline as a ship longer than 4 football fields glides silently toward the harbor. On its deck, more than 24,000 colorful steel containers carry everything from smartphones and medicines to coffee beans and car parts. Every single minute that vessel remains at the dock costs thousands of dollars, yet within hours, thousands of containers will disappear from the ship with astonishing precision. But here's what nobody tells you. What looks effortless is actually one of the most complex engineering performances on Earth. Most people see stacks of containers and a few giant cranes, then move on without another thought. But beneath that calm surface, thousands of workers, autonomous vehicles, powerful computers, and millions of sensors coordinate every movement down to the second. One small mistake can delay entire supply chains across continents. Today, we're going behind the fences and inside the hidden world where global trade never sleeps. Think about this. Nearly everything inside your home has probably passed through a container port at least once. The chair you're sitting on, the clothes you're wearing, the computer you're watching this on. Even the coffee in your cup may have crossed oceans inside a steel box. What happens next surprised even experienced engineers, because moving a container is only the beginning of an incredible journey. Before a container ever reaches a port, someone has to build it. More than 95% of the world's shipping containers begin life in factories across China, where enormous steel mills transform raw iron into massive coils of weather-resistant steel. The journey starts even earlier, deep inside iron ore mines in Australia and Brazil, 2 countries that together supply hundreds of millions of metric tons of iron ore each year. Imagine giant haul trucks carrying loads heavier than entire passenger airplanes, feeding crushers that never seem to stop roaring. The ore travels thousands of kilometers aboard bulk carriers before arriving at giant steel plants. Inside blast furnaces operating at nearly 2,000 degrees Celsius, iron ore combines with coke made from metallurgical coal and carefully measured limestone. Intense heat removes oxygen from the ore, producing molten iron that glows brighter than the afternoon sun. The air shimmers with heat, sparks fly through the darkness, and every step demands incredible precision. Next comes refining. Oxygen blasts through the molten iron at tremendous speed, burning away excess carbon and unwanted impurities until high-strength steel begins to take shape. Engineers constantly monitor the chemical composition because even tiny variations can reduce durability after years of exposure to salty ocean air. Most people never think about this, but a shipping container may spend decades crossing some of the harshest environments on the planet. He refined steel rolls into enormous sheets before robotic cutters slice them into precise panels. Corrugations press into every wall, adding strength without adding unnecessary weight. Those familiar ridges aren't just for appearance. They allow a container weighing around 2.2 metric tons to safely carry more than 28 metric tons of cargo. That's like asking a pickup truck to support the weight of several fully loaded city buses. Meanwhile, another supply chain quietly supports the container itself. Hardwood flooring often comes from sustainably managed forests in Southeast Asia or South America before undergoing kiln drying to reduce moisture. Specialized marine-grade paint protects every steel surface from corrosion caused by saltwater, ultraviolet sunlight, and years of constant handling. Every material serves one purpose: surviving millions of kilometers at sea. Meanwhile, another supply chain quietly supports the container itself. Hardwood flooring often comes from sustainably managed forests in Southeast Asia or South America before undergoing kiln drying to reduce moisture. Specialized marine-grade paint protects every steel surface from corrosion caused by saltwater, ultraviolet sunlight, and years of constant handling. Every material serves one purpose: surviving millions of kilometers at sea. Building one standard shipping container requires several metric tons of steel, hundreds of precision welds, heavy-duty locking hardware, rubber door seals, marine-grade plywood flooring, and protective coatings engineered to withstand years of punishment. Each finished container represents materials gathered from multiple continents before they finally come together in a single factory. The hidden supply chain begins long before global trade does. But the story doesn't end when the container leaves the factory. It must travel by truck and rail to one of the world's busiest ports, where an entirely different kind of engineering masterpiece takes over. Thousands of containers arrive every single day, yet somehow each one finds exactly the right ship at exactly the right moment. And that's where our journey becomes even more extraordinary. As the container ship approaches the harbor, the work begins long before anyone sees a crane move. Up to 48 hours before arrival, the ship sends a detailed digital cargo manifest listing every container, its weight, destination, hazardous classification, and exact position on board. Powerful planning software calculates thousands of loading and unloading moves in minutes, ensuring the vessel remains perfectly balanced throughout the operation. Imagine solving a giant three-dimensional puzzle where every wrong move could affect a ship weighing more than 200,000 metric tons. The moment the ship enters the channel, experienced marine pilots climb aboard from small pilot boats, often while both vessels remain in motion. Working alongside tugboats capable of producing more than 70 tons of pulling force, they guide the giant vessel toward the quay with astonishing accuracy. From the bridge, every command feels calm, but outside, engines rumble, propellers churn the water into white foam, and thousands of tons of steel respond to movements measured in mere degrees. The moment the ship enters the channel, experienced marine pilots climb aboard from small pilot boats, often while both vessels remain in motion. Working alongside tugboats capable of producing more than 70 tons of pulling force, they guide the giant vessel toward the quay with astonishing accuracy. From the bridge, every command feels calm, but outside, engines rumble, propellers churn the water into white foam, and thousands of tons of steel respond to movements measured in mere degrees. Once safely alongside the berth, the ship becomes part of an enormous machine. Heavy mooring lines secure the vessel while giant rubber fenders absorb the remaining energy from the docking process. Within minutes, ship-to-shore cranes begin moving into position, their steel booms stretching more than 70 meters over the water. Standing beneath one feels like looking up at a moving skyscraper made entirely of steel. Now comes the operation that fascinates engineers around the world. A crane operator, sitting nearly 50 meters above the ground, or sometimes controlling remotely from a comfortable office, lowers a steel spreader onto a container. 4 twist locks rotate exactly 90 degrees to grip the corner castings, creating a secure mechanical connection in just seconds. Cameras, laser sensors, and precision controls help align everything within only a few millimeters. With the container locked in place, electric motors quietly lift loads weighing up to 65 metric tons. Steel cables race over giant pulleys while sophisticated anti-sway systems constantly adjust the motion, keeping the container remarkably stable despite wind and movement. The hoist motors spin at carefully controlled speeds, allowing a complete lifting cycle to finish in less than 2 minutes. From below, you hear little more than the soft hum of electric machinery and the occasional metallic click echoing across the terminal. As soon as the container touches the ground, another carefully timed sequence begins. Autonomous guided vehicles, or AGVs, roll silently beneath the crane, collecting containers without a driver. Guided by GPS, LiDAR, cameras, and embedded navigation systems, these electric vehicles travel at speeds of around 20 kilometers per hour while maintaining safe distances from every machine around them. Most people never notice them, but together they create an invisible highway across the terminal. The containers arrive at the storage yard, where towering automated stacking cranes organize them into neat rows that can reach 6 or more containers high. Every location has a unique digital identity, allowing computers to know exactly where each container sits within seconds. Imagine a warehouse so large that it covers hundreds of football fields, yet software can still point to one specific container without hesitation. The containers arrive at the storage yard, where towering automated stacking cranes organize them into neat rows that can reach 6 or more containers high. Every location has a unique digital identity, allowing computers to know exactly where each container sits within seconds. Imagine a warehouse so large that it covers hundreds of football fields, yet software can still point to one specific container without hesitation. Behind every movement lies an invisible digital network. Thousands of RFID tags, GPS receivers, weight sensors, optical cameras, weather stations, and communication systems exchange information every second. Artificial intelligence predicts equipment conflicts before they happen, reroutes vehicles around congestion, and constantly searches for faster ways to move cargo. What looks like organized chaos is actually millions of tiny decisions happening almost instantly. A single modern quay crane can move more than 35 containers every hour, while the world's busiest ports handle well over 40 million TEUs, 20-foot equivalent units, every year. Every delay matters because one late shipment can ripple through factories, warehouses, and stores across the globe. And this is where it gets truly extraordinary, because moving containers efficiently isn't enough. They must also survive some of the toughest quality and safety inspections in modern industry. That's exactly where we're headed next. By the time a container reaches the terminal, the toughest part isn't moving it. It's making sure every movement happens safely. A single damaged container can threaten valuable cargo, delay an entire vessel, or even endanger workers. That's why modern ports rely on a combination of advanced automation and experienced professionals who constantly monitor every operation. Most people never think about this, but safety begins long before the first crane starts lifting. Before unloading begins, high-resolution cameras scan every visible side of the ship. Artificial intelligence compares each container against thousands of reference images, searching for dents, corrosion, cracked welds, damaged corner castings, or missing identification numbers. Advanced image processing software detects defects that are only a few millimeters wide, allowing inspectors to respond before small problems become major failures. What once required hours of manual inspection now takes only a few minutes. As each container leaves the ship, it rolls across an automated weighbridge equipped with precision load cells. These systems measure weight with remarkable accuracy, often within a tolerance of less than 0.1%. If the measured weight differs from the shipping documents, the container immediately receives a digital alert for further inspection. One overloaded container can affect the stability of an entire ship, so every kilogram matters. Radiation detectors, hazardous material sensors, and thermal imaging cameras quietly inspect thousands of containers every day. Thermal cameras instantly identify unusual heat patterns that could indicate chemical reactions, electrical faults, or hidden fires developing inside sealed cargo. Radiation portal monitors screen every passing truck without slowing traffic, helping customs agencies maintain security while keeping global trade moving. Behind the scenes, technology works continuously, even when nobody notices. Radiation detectors, hazardous material sensors, and thermal imaging cameras quietly inspect thousands of containers every day. Thermal cameras instantly identify unusual heat patterns that could indicate chemical reactions, electrical faults, or hidden fires developing inside sealed cargo. Radiation portal monitors screen every passing truck without slowing traffic, helping customs agencies maintain security while keeping global trade moving. Behind the scenes, technology works continuously, even when nobody notices. The cranes themselves never stop checking their own health. Hundreds of sensors monitor motor temperatures, gearbox vibration, cable tension, hydraulic pressure, and structural stress every second. Predictive maintenance software analyzes this flood of information, warning engineers days or even weeks before a component begins to fail. Instead of waiting for a breakdown, technicians replace parts during scheduled maintenance, keeping the port running around the clock. Automation handles much of the heavy lifting, but human experience still makes the difference during unexpected situations. Strong crosswinds, unusual cargo shapes, or emergency operations often require veteran crane operators to take direct control. Years of experience allow them to anticipate tiny movements that even sophisticated algorithms sometimes struggle to predict. In those moments, human judgment still outperforms the smartest machines. Quality standards extend far beyond the port itself. Shipping containers are built and inspected according to internationally recognized safety requirements before entering global service. Engineers perform compression tests, lifting tests, floor strength tests, watertight inspections, and repeated door operation cycles to ensure every container can survive years of loading, unloading, storms, and rough ocean crossings. A container that fails these inspections never enters the global supply chain. Even after years at sea, every container continues receiving routine inspections. Inspectors check weld seams, locking mechanisms, flooring, corner castings, and corrosion levels before approving another voyage. Only a small percentage require major repairs, while severely damaged units are retired and recycled into new steel products. That constant cycle of inspection and renewal keeps billions of dollars worth of cargo moving safely across the world's oceans. Take a step back for a moment and imagine looking at Earth from space after sunset. Thin lines of light connect continents as thousands of ships move across the oceans, quietly carrying the products that keep modern life running. Today, more than 90% of world trade by volume travels by sea, and almost all of it passes through container ports at some point in its journey. Most people never see this invisible network, yet it powers nearly every economy on the planet. Every year, the world's container ports handle well over 850 million TEUs, or 20-foot equivalent units. If those containers were placed end to end, they would stretch around the Earth many times over. Together, they move trillions of dollars worth of goods, making container shipping one of the largest logistics systems ever created. What looks like rows of colorful steel boxes actually represents the heartbeat of global commerce. Today, China operates the largest share of the world's busiest container ports, handling roughly 30 to 35% of global container throughput. Singapore remains one of the world's most efficient transshipment hubs, while South Korea, the United States, and the Netherlands continue to rank among the global leaders in advanced port operations and international trade. Each country plays a unique role in keeping goods flowing smoothly across oceans every single day. But here's something remarkable. Back in the 1950s, loading a cargo ship often took more than a week because workers handled individual boxes, barrels, and crates one by one. The invention of standardized shipping containers transformed global trade almost overnight, reducing loading times from days to hours and dramatically lowering transportation costs. That single innovation changed manufacturing, retail, and international commerce forever. Over the past 50 years, container ships have grown from carrying just a few hundred containers to transporting more than 24,000 TEUs on a single voyage. Modern cranes reach higher, lift faster, and operate with astonishing precision, while software coordinates millions of cargo movements every year. The entire industry continues to evolve because global demand never stands still. Okaying ahead, engineers expect smarter ports powered by artificial intelligence, fully autonomous electric equipment, hydrogen-powered cargo vehicles, cleaner shore power systems, and digital twins that simulate entire terminals before equipment even moves. These technologies promise faster operations, lower emissions, and greater resilience against disruptions. The ports of tomorrow won't just move containers. They'll think, predict, and optimize almost every decision in real time. Did you know that the largest container ships are longer than 4 football fields placed end to end? Did you know a single modern port can move tens of thousands of containers in just one day? And did you know that if global container shipping stopped for only a short time, supermarkets, hospitals, factories, and online stores around the world would begin feeling the impact almost immediately? Suddenly, those colorful steel boxes don't seem so ordinary anymore.